In 3.2, we will solve inequalities in two variables. But before we look at two variables, let's go back and review an inequality with one variable. For instance, 3x minus 5 is less than or equal to 13. If you remember, we solved this inequality the same way we solved an equation. We would start by adding 5 to both sides, which would give us 3x is less than or equal to 18. And then we would divide both sides by 3, which gives us x is less than or equal to 6. We can graph that solution on a one-dimensional number line. We would mark our 6, and then since we have an equal to on our inequality, we would put a solid circle at that 6. And that serves as the boundary between answers that are true and answers that are not true. To get the answers that are true, we need values that are less than 6, so we would shade to the left. And if we were unsure at all, then we could just pick a value that is to the left of 6, like 0, and substitute it in. 0 is less than or equal to 6, so we know we need to shade on that side. Now, before we move to solving the inequalities in two variables, let's remember how to graph a line. We just did this in the last lesson, so this will be a quick review. If our equation is solved for y, like it is in number 1, then we can read our slope off of the equation. It's the number that's in front of x. And we can read our y-intercept, which is the other number. Remember to take the sign with that. So we're going to graph our y-intercept at -4. And from that y-intercept, we can count a positive slope of 3/1. So up 3 and to the right 1. We should have an uphill line. This line is going to serve as the boundary when we have an inequality. Let's look at the next example. This is solved for y, so we can read our y-intercept of 1, and from that y-intercept we count a negative slope, -2/1. So I can go down 2, which is a negative direction, and to the right 1. I could also go up 2 and to the left 1. I just need to make sure that I have a downhill line because I have a negative slope. Equation 3 looks a little bit weird because I'm saying that we're graphing in two dimensions, x and y, but there's no x in our equation. Think about why that might happen. If my slope is 0, then I have 0 times x plus 2. But we don't usually write 0 times x because that's going to simplify to just 0. And that leaves us with the equation y equals 2. If our slope is 0, that means we have a horizontal line. Another way to think about that is that y is equal to 2 regardless of what our x value is. So if our x value is 0, y is 2. If our x value is, say, 3, then y is 2. And once I have 2 points, I can draw the line connecting those points. That horizontal line has a slope of 0. Now question 4 looks really strange. It has no slope at all. And if we have no slope, because we have no y value, then that means that we have a vertical line. And we can think about this way. X is -3 regardless of what y is. So y can be anything. X is always going to be -3. So I can plot -3, 0. I can plot -3, 3. And you can see that those points lie on a vertical line. And as I said, these lines will serve as boundaries for our inequality. We're going to shade on one side of the line or the other, depending on whether we want greater than or less than. And that's where we're headed next. On number 5, we want to circle all the ordered pairs x, y that are solutions to the inequality y is less than 2x minus 3. Just like we did with equations, we can substitute in our x and our y and see if we get a true statement. If we get a true statement, then we circle it, it's a solution. If we get a false statement, then we know that that point is not included in the solution set. So when we substitute 0 for x and 0 for y, we get 0 is less than 2 times 0 minus 3. 2 times 0 is just 0, so 0 is less than negative 3. That's a false statement because 0 is greater than negative 3, which means that this is not a solution to our inequality. Let's try another. Let's let x be 2 and y be 0. So 0 is less than 2 times 2 for my x value and minus 3. 2 times 2 is 4. So 0 is less than 4 minus 3. 0 is less than 1. Well, that's not true either. Oh, actually, that is true. If that is true, then that means that this is a solution. It's one of many solutions to the inequality. Pause the video and try the next 3 ordered pairs to determine if they're solutions. Go ahead and check your results with mine. Make sure that you're substituting the second value in the ordered pair for your y and the first value in the ordered pair for the x. If you get those backwards, then it doesn't mean the same thing. In our last ordered pair, notice that I got negative 3 is less than negative 3. That's a false statement because those are equal to each other. Now, if I had had an equal sign on my inequality, like this, which means that it would have been on the original, like that, then I would have said that is a solution. But since the equal sign was not on the inequality, that is not a solution. As I said earlier, a line is going to be the boundary for our shading. We're going to shade on one side or the other. Sometimes we want to include that boundary, and sometimes we don't. If we're looking at y is less than 2x minus 3, since we don't have an equal sign on there, we don't want to include the boundary, and we need a way to show that. And here's how we'll do it. If we have a solid line, then that means we want to include the boundary. Include the line. But if we don't want to include it, then we're going to use a dashed line. To get our boundary, we're going to graph the equation y equals 2x minus 3. So we have a y-intercept at negative 3, and then we're going to count a slope of up to over 1. Now we do not want to include that on our inequality because we just have y is less than 2x minus 3. So we're going to dash that line instead of making it solid. Now we have to decide which side of the line to shade, and there are 2 methods for doing that. One method is to use a test point. So pick any point. The easiest one is the point 0, 0, which is the origin. We've already substituted that into our equation in number 5. It was our first test point, and we found that that did not satisfy the inequality. Since it did not satisfy, that means we want to shade on the side that's opposite that test point. Another way that we can determine the shading on the inequality is to shade above or below. So let's sketch in our boundary line again. And since my inequality is solved for y, I can put my pencil anywhere on any point on that line, and I can think, are the y values going to be less than if I shade above that point or if I shade below? And the y values will be smaller if I shade below. So you can think in terms of above and below to do your shading, as long as your inequality is solved for y. If we're given an inequality that's in standard form, meaning the x and the y are on the same side of the inequality symbol, then we can either solve that for y and use the methods that we did on the previous problems, or we can graph our boundary line using x and y intercepts and then use a test point to decide which side to shade on. So I'm going to make a little table for my x and y intercepts. To find the y-intercept, I'll let x be 0. To find the x-intercept, I let y be 0. I'm using an equal sign when I find the x and y intercepts because I'm just looking for the boundary. If x is 0, then negative 0 is still 0, and I have negative y is equal to negative 3. If I divide both sides by negative 1, then I get a positive 3. If I go back to the inequality and I let y be 0, then I get negative x is equal to negative 3. If I divide both sides by negative 1, then I get x is equal to 3. Now I'll plot those intercepts, 0, 3 for the y-intercept and 3, 0 for the x-intercept. There's an equal on my inequality symbol, less than or equal to, so I want a solid line for this boundary. To determine which side to shade, I'm going to choose a test point, and I'm going to use 0, 0 since it's not on the boundary line. If I put 0 in for x, then I get negative 0, which is just 0, minus 0 is less than or equal to negative 3. So on the left side 0, less than or equal to negative 3. That's a false statement because 0 is greater than negative 3, which means that I'm going to shade on the opposite side of the boundary line. And that's how you solve an inequality in two variables.